So today I was kind of debating what to talk about. Well, first thing, I did want to touch up on working memory really fast. There was a quick point I missed after explaining all the mechanism stuff about how working memory works. Basically, it's a short-term memory buffer, and the bigger it is in your brain, like say the more digits you can hold in your brain, or the more shapes, the more complexity of the shapes, things like that. Uh, Generally, like the more you can do, especially on like an IQ test or something. Um, I sort of missed the a big punchline of that, which I guess could be a separate topic in itself, which is how can you get better at that? I kind of touched on some of these training programs that don't work really well, but there are obviously things you can do to get better, and it's just they're not as maybe flashy or interesting, but people get better, all the time in all different domains. And one thing they do is they learn to map stuff. So I guess we'll just do working memory again today. Um, Working memory, how to get better. I was going to do a different topic, but I realized as I'm talking, there's probably two things I forgot to mention. Hopefully I can remember. Hopefully I can keep that in my working memory. So there's really two strategies to getting better in working memory. One is mapping. So this is this is a thing you get better at when you're in a field for a long time, or say you play in a game very well. So I don't know what kind of games chat here plays, but the I guess the classic example is a chess player who, instead of remembering all the different, my chessboard is going to be abbreviated. It's usually 8 by 8, but instead of remembering every single piece and every single square, they kind of start to remember configurations. That this is kind of like a shape to them. It's a situation that happens a lot, and maybe this happens in a corner of the chessboard, and it can be transitionally rotated and put in different places. But it basically gets mapped in their brain as, you know, whatever X situation. So whenever they see this, it kind of triggers this whole thing, this whole stored thing that they've seen many times. So if they're, say, mapping a bunch of different moves and they realize 3 moves, they're trying to think, say, 5 moves ahead, and they realize, okay, if I move here, this person could move these different ways. I'm going to think through each one, and if I move there, this situation can happen. They're it's almost like an icon on your desktop. They're just referencing something that they've already put a lot of work into storing, referencing. This is something they've probably just encountered over and over again, so they remember it well. So there's the idea of mapping, which is that when you start off with something new, the level of detail and complexity isn't it's like trying to capture a photo, like a full panoramic photorealistic photo all at once. You're you're not doing that. You're capturing things in layers of abstraction. You're you're realizing there was, say in a photo that there was probably 3 people over here, and there was one person talking to one person here, and so this is, say, like mapped as a conversation between 2 people. And if somebody asks you to reconstruct this image, you might start to draw these people out based on the features that you remember about how people look. But it's not that you necessarily remember all these features I'm drawing now. You don't necessarily remember that they were facing each other. You didn't capture and store all this. You just simply captured that there was 2 people talking to each other. Now you're like this mapping concept. So to kind of go back to the chess thing, they might realize, oh, if their opponent makes a separate move, they'll end up in a different kind of situation, and that maps to another situation. So this stuff just grows with experience. I don't know. We can throw a lot of technical words on it, but it's basically mapping. And let me just write that out here. Mapping. So that's one way you can get better. So the idea is, so you can do this with even sequences, numbers. So you can remember really long sequences of numbers. You can do this with, I mean, your brain just starts doing this over time with everything. I mean, your brain at every layer is automatically creating maps over time. You just have to give it enough exposure and time and to consolidate and learn these things. And then, of course, another thing you can do is patterns. So this is more obvious with numbers, but if you have like 2, 4, 6, 8, 10, 12, 14, you see the pattern. So if I ask you to remember this, you're not going to actually remember 7, 1 and 2 digit numbers. You're just remembering the pattern. Maybe you remember the where it begins and ends. I'm just gonna color these in. You're like, okay, it started at 2, oops, ended at 14, So you actually end up remembering only maybe 3 pieces of information instead of the whole thing. You remember the starting number, you remember the ending number, and you remember like the pattern itself. So this is the idea, and this gets into information theory, which is all computer systems, intelligence itself is all based on. It's based on patterns because patterns allow you to reduce information into a smaller representation. So there's a lot of bigger concepts this stuff branches to, but it's worth touching on really fast here because if you want to get better at working memory, which is the definition again, which I should have started at the beginning, it's sort of the chalkboard of your mind, the blackboard of your mind. These are 2 things that your brain kind of naturally does, but you can be more aware of and work on explicitly, especially if you want to get better at something in particular. So that's it. Let me think if there's anything else I'm going to regret not covering really fast. I did want to keep today's pretty short. Yeah, so I mean, people that say like rotate, very complex objects in their head or something like that, that can just be a consequence of practice. And so, for instance, specifically on that, if that interests you, you get used to looking at things from different points of view, so that I'm not going to be able to draw this or do this, but the idea just being that, very simply, something complex as a hand. If you look at like this, that has a silhouette, and if you look at like this, that has a silhouette. So you could draw those 2 silhouettes, and that's sort of a flattened representation of a higher dimensional object, right? And I'll try to draw those really fast. So you have like, from the side, you have like this, and then you have like this. Whatever. Not great drawer, especially with my mouse. But so what people are doing in their mind is they're referencing these things, and they're building up rich libraries over time. Trying to think of a better example here of mapping or pattern recognition. I mean, there's a million examples in games. Like people learn to recognize certain situations in FPSs. Actually, okay. So there's another interesting one. There's one called they call subsitization, which is it's a fancy. I'm just gonna put example subsitization if you want to look that word up. Let me make sure I spelled that right. Subsitization. Oh. It's subsitizing. Yeah, that's they're trying to correct this to like subsidizing as in financial, but subsidizing. Okay. Oh. That's how you spell it. So the idea is like you've probably seen this example or you've heard of this where sometimes in movies they'll have this where like a savant, like an autistic savant will count a bunch of objects that are dropped really fast on the ground, like, oh, it's 73 straws or something. It's kind of ridiculous. But the idea is like one way to actually do this over time is, if I quickly draw this and then you didn't see me draw this, I just showed you really fast and then asked you how many objects are in this box. You can learn to recognize this as 5 really fast because there's sort of a pentagon shape to it, and there's only so many shapes that 5 things can create. There's like you could have a box with a thing on here, etc., etc. Anyway, these are kind of concepts of mapping and pattern recognition. So the idea is, if you want to get better, if you feel like you can't hold things in mind very well with what you're doing, say like just in conversation, like right now I'm trying to talk about this stuff and I'm trying to reference concepts and keep them in my head, and new ones are popping in my head as I'm talking, and I'm trying to store that on kind of like a to-do list in my head so I don't forget it when I come back to it. One thing that's really helping me out here is I've dealt with these concepts before. I've either written them out to myself, I've worked with them, I've read about them, I've talked to them with other people. So they're more icon representations rather than me trying to store this whole thing in my head. And so if you find yourself just getting overwhelmed, know that you just probably have to work on this mapping first. And then after a while, you can just simply reference sort of the icon representations, and then you can start having the, you can keep these things in your mind. So, say X and a triangle just represents 2 different chess positions. I can just simply remember, this position, and by name or reference. And then I'm talking about something else right now, and then I can return to these later because I'm not trying to actually remember 5 or 10 or whatever pieces in a 64 position board. So that's it. Yeah, so I guess this is a working memory part 2. But yeah, that's something to work on, I guess. We can get more specific later. I'm still trying to feel this stuff out. That kind of ends our daily knowledge bomb. So if you want to improve that chalkboard of your mind, I'd say work on the sort of the pieces of whatever it is you're interested in, whatever it is you're trying to get better at. And it's kind of similar with like sequence learning. If you're trying to get better at music, or if you're trying to get better at like pulling off a move in a game that's very click intensive, break it down, work on the smaller pieces first, make sure they become reflexive, and practice, say, circling around into if you're playing a first player shooter, practice circling around into a room and tossing maybe you want to toss the nade, circle in the room, take a pot shot at this angle and this angle as you enter the room. That's 4 pieces. That's a lot to practice. You can practice that, and then you can practice. You can work on like one other sequence where you do some other combination of grenades, guns, whatever the game is, and whatever you're trying to do. That's it. Now you have 2 map sequences, and that takes a while to build those 2 up. But now when you approach that situation, you're making a higher level decision about which one of those 2 you're going to do. But before you can even do that, you need those sequences down. And it's the same thing with fields and concepts and stuff like that. You're trying to build these pieces so that they're there for you. And then the chalkboard of your brain can only handle so much. I mean, kind of like my crummy Microsoft Paint setup here. This is just Microsoft Paint with a black fill-in. There's only so much I can draw on here before I fill it up, and before it becomes really cluttered. So what you try to do is I try to use representations that you guys will recognize, like my really bad face. There, smiley face. I'm trying to subliminally make my viewers happy. All right, so that's it for today. Working memory part 2 done.